Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is going over primarily, and we are on year number, so let's go ahead and get started. Let us go ahead and get rolling with our 2003 Form B question, which was a very good one, and it has a lot of stuff in here that can be a little challenging. So let's go ahead and get rolling. Now, with the second FTC, you notice in the previous two videos that we've done, you're either given g of x equals the integral of your function, or you're given f prime, right? Usually it's one of those two, and you'll notice that it varies every year on which one they give you. So if you take a look here, they gave us g of x equals the integral x2 and then f of t dt, right? Well, we got to find these three values right here. So let's go ahead and do them. Well, how would we solve these out? Well, you would do them just like you normally would. You would write g of 3 is equal to, we get g of 3 is equal to, we get the antiderivative from 2 to 3, right? We just plug the 3 into the x, and then what does the antiderivative tell us to do? Well, the antiderivative tells us to find the area under the curve. Well, the area under the curve from 2 to 3 is a trapezoid. Well, if you remember trapezoids, this is how they work. You have two different lengths. So we have the length at 2 is 4, so it's going to be 4 plus, what's the length at 3? 2, right? Divided by 2, because we want to take basically the average of the two so that we get like a rectangle that ends up actually being right here, but nonetheless we'll be okay. And then what's the width? Well, from 2 to 3 is 1, so times 1, so this is going to be 6 over 2 times 1, 3. So g of 3 is equal to 3. Well, how do we do g prime of 3? Well, g prime of 3, before we start, we need to take the derivative of this function right here. Well, if I take the derivative of g of x, that'll be g prime of x like this. And then when I take the derivative of this right side, derivative and anti essentially cancel each other out. But if you were to think about this, like, how would you go about doing this? We would take the antiderivative, we'd plug in our x, we'd plug in our 2, right? Well, then we would take our derivative, which would undo it. But remember, this would just end up becoming f of x, because at some point when we do the anti, we got to plug this x into for t. The 2, we plug it in. F of 2 is just a number. The derivative of a number is 0, right? So we would get some antiderivative, like, let's say antiderivative f of x minus, f of 2. And then we take the derivative, this is gone, antiderivative cancel, and then we're left back with f of x. So this is our function. So let's go ahead now that we've defined that, which we have to write on the AP exam, let's go ahead and plug it in. So if I want to find g prime of 3, I need to figure out what f of 3 is. Well, g prime of 3 is just f of 3. So let's look what we're given. Well, we're given the graph of f. So what is the y value at 3? At 3, it's 2. So we can conclude that this would be 2. Let's go ahead now and find g double prime of x. G double prime of 3. Well, I'm going to take the derivative from up above, so this will be g double prime of x is equal to f prime of x, like this. Now we'll go ahead and plug it in. So we're going to get g double prime of 3 is equal to f prime of 3. There it is. So now, if you take a look, okay, so now that we plugged in g double prime of 3 equals f prime of 3, we need to take the derivative at 3. Well, the derivative at 3 is going to be this tangent line right here. This is the little tangent line that you see at 3. Well, here's a little bit of the issue. And the issue is really this right here. This is a straight line. This is good because the tangent line is the slope of our straight line. So all we have to do is rise over run to get our slope of this line, because it is a straight curve, right? So I'll take this rise over run from these points here. So I'll write this out like this. Maybe I'll write this as x1. This will be x2. So I'll go over here, 3 minus 2, and this is 2 minus 4. Remember, our slope should be negative. We're going to get negative 2 over 1, so our slope is negative 2. So over here, I would maybe have written it 2 minus 4 divided by 3 minus 2, and then we would get our negative 2. So there it is. We have answered all three parts to this problem for part A. Let's go ahead and move to part B, which can be a pretty confusing one. Let's go to part B. First things first, it says find the average rate of change of G on the interval here, right? Average rate of change, well, we could actually do this in two different ways, but we know average rate of change means rise over run. So what I'm going to do is I'm going to write G of 3 minus G of 0 divided by 3 minus 0. Now the good news is we already know what g of 3 is. We did this right here. G of 3, if I remember, let me go ahead and bring it back. G of 3 was 3. So I can go back to this problem and I pretty much have almost all of it done. 3 minus, and then we have 3 down below. All we need to do is find g of 0. Well, how do we find g of 0? Well, we're going to plug it in up here and do it just like we did in the past. So we're going to write g of 0 is equal to, so we're going to get g of 0 equals, we put the 0 up for the x right here, and you're going to notice that we have a little bit of an issue. This should always go from most positive, right? This is most positive to most negative. That is not the case, so we need to flip these two. Now, if you remember, when we flip them, we put a negative on the outside. I'm just going to put a -1 times your integral, because that's really essentially all it is. Remember, if you're flipping your integral symbols, you're just making your area the opposite sign. So if you look here, we have it set up. We need to find the area from 0 to 2. Well, -1 times, well, what is the area from 0 to 2? Well, 0 to 2, it is a triangle, right? You can see it's a triangle right here. So this is 2 times 4 is 8, divided by 2 is 4. So we get that this value is -4. So now I can go in here and put -4. Right, you got to be a little bit careful because you have minus -4. This is going to become 7 over 3. So at the bare minimum, we found at least the first part of this right here. And this is important because if you were taking the AP exam, each one of these from part A is 1 point. So that'd be 3 points. And then this section alone is 1 point. So you're already at 4 out of 9 points, right? Let's go to part C. For how many values of C where for how many values of C where C is between 0 and 3 is G prime of C equal to the average rate of change in part B? This to me looks like the mean value theorem, but because it's given this weird integral here, it looks a little bit off. So what I'm going to write is this: G prime of C should equal 7 over 3. Right? We want the derivative to equal the average rate. We found the average rate. The average rate is right here. And we want the derivative to be that. Well, here's the good news. We already have this expression right here. G prime of x equals f of x. So if we plug in C, we're trying to find some C value. G prime of C is f of C. So we're going to look at our graph. Is there some values, some C values, where this is equal to 7 over 3, right? Because the only way to answer anything about G is to look at f. Well, let's go to our graph. Is there any values that are 7 over 3? Well, there is, right? Because if you look over here, we're going to look up above 7 over 3. Well, let's take a moment to think about this, right? Well, what's 9 over 3? 9 over 3 is 3. So 7 over 3 has to be under 3. And we're thinking about the y values, right? How many y values does this function have? That is 7 over 3. So I'm assuming 7 over 3 without grabbing a calculator is something under 3. Well, if I look, there is 1 point right here. And there's another point right here, right? Some point probably here is 7 over 3. And some point over here is 7 over 3, and this is like 1.5 or something. This is maybe 2.6 or something like that. So if you look, this was very tricky because yes, this does scream mean value theorem, but because it was given this right here and we can kind of just work our way through it, we didn't necessarily need it. Now we can write down in our problem, we can say right here that we're going to write down there are 2 values of C in this interval right here. There's 2 values of C in this interval where G prime of C equals 7 over 3 because G prime of C equals f of C equal to 7 over 3 has 2 values, has 2 potential values, and then that is our justification. Find the x coordinate of each point of inflection of the graph of G on the interval 0 to 7 on the open interval. Well, if you remember, points of inflection are when G double prime of x, because it's asking about G, so G double prime of x is equal to f prime of x, and we want this to change signs, right? Either from positive to negative or negative to positive. The reason why is, remember what a point of inflection is. Let me draw this graph. Your point of inflection is this point right here. It is when your graph changes concavity, and that is when your second derivative needs to change from positive to negative or negative to positive, right? And this is the original, right? This is the original here. The difference is in this graph here, we're talking about g. So when we do the second derivative, we're gonna get g double prime of x equals f prime of x. Well, I need to take the derivative of this graph. If I take the derivative of this graph, the derivative here is undefined. I'm gonna write a u. The derivative here is undefined. I'm gonna write a u. But guess what? It doesn't matter because, well, if I take the derivative of this graph, I'm taking the derivative, right, of this graph, and it gave me f, so I need to take the derivative. This slope right here is 100% positive, right? This slope right here is 100% positive, and this slope right here is 100% negative, and then this slope right here is positive. So positive to negative, this is the point of inflection. This is negative to positive, right? Negative to positive, this is a point of inflection. So I would say, so we'll say at x equals 2 and x equals 5, the graph of g on the interval 0 to 7 has points of inflections because g double prime of x equals f prime of x changes signs. I don't need to say that 2 changed from positive to negative and 5 changed from negative to positive. We just know to be a point of inflection, your second derivative has to change signs. So hopefully that makes sense. That's going to take care of 2003 for y'all. Capiche?